ended up with uncontrolled spikes into the facility, all sorts of things that were just bad for electronics.
You're at your peak season and you have 30 or 40% of your factory go down. Your customers will be affected.
It sent a shockwave through the whole facility, and we lost probably $80,000 worth of controllers that day.
At the facility, we see brownouts in the summer, which cause our lines to go down, and many times we see the entire factory go down. It's just a little blink, but that shuts down all the equipment, which causes us anywhere from 2 to 4 hours of downtime for the entire facility.
We had an idea what the problem was, but we weren't really sure. So we brought in some outside help to record and monitor what our incoming power was from the utility. They came back with a pretty bad report, really, of how our power was fluctuating. We ended up with uncontrolled spikes into the facility, all sorts of things that were just bad for electronics.
We dug in a little deeper and found out what types of problems they were and what they were. They were having problems with drives and fuses, and their lighting ballasts were failing sooner than they should have. Just a multitude of different issues were going on.
The plant was having a lot of power failures, and every time we had a power failure, you'd lose VFDs or panel views, oven controllers, PLCs. Sometimes we'd lose $40,000, $50,000 worth of controllers in one shot. It's disheartening on the people, especially the maintenance guys. They may go the whole day without break depending on what time the outage happens. We've had no capacitor banks, no surge protection in this facility, so every time there was an outage, they just get ready to replace equipment. They became proficient at reprogramming these units, and that shouldn't be. When you have to put a VFD in, you should have to scratch your head and think about it. This was becoming second nature to these guys because they do it so often.
So all of our lines here, it's frozen product. And we had an event where we had a ammonia compressor go down. And certainly that event will keep 1 or 2 lines down for a certain amount of time, which in this case it was, I believe, 5 or 6 days. So the loss was tremendous as far as productivity and customer service.
We had the initial discussions with maintenance with Bruce Whitmer in the electrical maintenance, who was seeing the day-to-day issues, and it was fairly quickly bumped up to Greg Chartrand, and then ultimately to Will Miller out of Nebraska. And so the discussions we had with upper management was how fast the return on investment was going to be for this facility. And through calculations, knowing what money they have spent and what downtime they've had in the last couple of years, it was a pretty fairly quick estimation that we could make that they were going to see a return on investment within about 4 months. And so when you look at a 4-month return on investment with the amount of dollar value that they have lost over the production time in the last 12 months, when you start to add those up, the life cycle savings over the 30-year warranty was going to be in the $10 to $15 million range. So for a $250,000 expenditure, you're now protecting the facility for 30 years with a $12 to $15 million payback.
So within the solution, we're looking for something obviously that will stop the downtime we're seeing in the plant. The company provided a 30-year warranty, which gave us a lot of confidence that the modules that we're going to put on the equipment would definitely work and last us long term. And then certainly we look for the power factor correction, which will save us money on our utility bills long term.
It's a fraction of the cost of what some people propose for power quality. I mean, this is something that a company can use and see the effects immediately. A lot of people will say, "Oh, I'm going to get solar panels or different things to help me save energy," and then that's all good. But your return on investment is usually about 10 years on that stuff.
The surge protection device is a sponge. So when a surge enters into a, like I said, piece of equipment or a CDP or an MCC, it is looking to dissipate and looking to go somewhere. And the surge protection device becomes the path of least resistance. It becomes the sponge in order to mop up that electrical surge.
A lot of devices have minimal surge protection components in them. There's a couple of MOVs, there might be a gated triac and some other components, and that's it. We designed our units a bit differently. We put a lot of effort into having a device that not only performs well, but is also has a lot of safety, because these devices can explode in the event of a large surge or lightning strike. Everything's getting so computerized, and the angstroms per inch are getting so dense that even the smaller anomalies now are causing issues. So the enhanced transient filtering that we have, that majority of suppression devices don't, makes a really big difference in the return on investment for our clients. Regardless of where that transient happens on the sine wave, we can pick it up quickly. And the problem that you have without that filtering at the category A or B levels, these transients cause degradative failure over time. It's not immediate failure like a lightning strike or a surge. It's more like stress on the body, where over time you're going to have a heart attack. So our devices are designed to last for a very long time. In the event that we have a failure, and we've had failures where lightning strikes has taken out our device, we've saved the client's equipment. That's the whole idea, that the purpose of that device, and then they get a free replacement.
Three common issues that happen with electronic devices. You're either going to have catastrophic failure, which means the PLC or the drive fails completely, or you're going to have intermittent delays or brownouts or intermittent lockups, which means that the supervisor or the operator generally has to reboot that piece of equipment, and there is downtime associated with that. The third thing which is overlooked is when the piece of equipment, the piece of electronic device, gets a signal that it can't process, and sometimes it will process it wrong. So now, instead of being at 78 degrees Fahrenheit for a process, it may take it to 87 degrees Fahrenheit.
Our next step was to do a site survey. So we walk through the plant and we find the areas that would benefit most from the surge suppression. Right? So that's how we do it, and then we'll put something together for the client, and they can review it, and we can discuss it and see how we're going to attack the issues. It was an ongoing process over several weeks where they would install, so I would come in each week and check on them and make sure how they were installing them and that sort of thing. And so we've built quite a good relationship.
Every time we had a question, all we had to do was call, and Monica would either deal with it over the phone or she'd show up and take our guys through it. And now every piece of equipment coming in, we'll have a unit put on it right away.
Working with Innosys Power was great, certainly very turnkey. They were able to work directly with our maintenance department here, and over the course of a weekend, install about 90% of the components required for a successful solution.
We can generally look at a facility, an industrial facility, a manufacturing facility like this, and we can generally protect the entire facility for less than 1% of the capital cost of their equipment for 30 years. So the investment is very small compared to the overall investment they've made in their production equipment.
Since May 2004, our lighting circuit alone has had over 500 hits. So the other thing was, when we have a power outage, we usually end up losing ballast, we lose lighting. So this is protecting our lighting system. So 500 hits, that's a lot since May. So the equipment's doing its job in protecting our equipment now.
You're not only protecting the equipment, but you're also protecting the process. And in the case of, let's say, Conagra or other food processing companies, you're also protecting the food goods that are going into the process so they do not go bad.
It's working at the end of the day. And I mean, our guys, after a power outage, the electricians are a little more comfortable. They're not going to have to run around with their trying to get the place back online and repair equipment, because it's just not happening. The plant starts up and away we go. And that's bonus for us, because we get everybody back online, everybody working a lot quicker now.
It's really satisfying to be able to see the results that we get. And yeah, people are always surprised on how well it works. So, and I'm happy. I'm going, see, I told you. So they're always happy when they get it installed.